Today, we are diving deep into a world that covers most of our planet but remains almost completely unseen. We're talking about the incredible hidden landscapes that lie beneath the surface of our oceans. It's a place of mystery, power, and unbelievable scale. It's so easy to look at the ocean and just see this big, flat, blue surface. But that's just the wrapper. Underneath, it's anything but flat. We're talking about a world with towering mountains, enormous plains, and canyons so deep they make the Grand Canyon look like a ditch. This landscape is shaped by some of the most powerful forces on Earth. So, here's our game plan. We're going to start our journey right from the coastline and travel all the way down to the deepest, darkest trenches, stopping at all the major landmarks along the way. Let's get started. Okay, first things first. Before we can explore, we need a map. So let's get the lay of the land, or the seabed, I should say. It all starts with understanding the major parts of this hidden world. When you strip it all down, geologists basically divide the ocean floor into four main zones: the continental shelf, the continental slope, the deep sea plain, and the oceanic deeps. Think of these as the fundamental building blocks of the entire underwater world. Our journey begins right where the land meets the sea, in a place called the continental margins. And no, this isn't just the beach. It's this whole massive transition zone where the continents finally give way to the deep ocean. The switch from land to sea isn't like flipping a switch. It's a gradual process. The coastline itself is shaped by features like bays and headlands, and as you move away from the shore, the water slowly gets deeper. This is the very beginning of that continental margin. So, this margin has three distinct parts. First up, you've got the continental shelf. It's pretty shallow, kind of like a submerged patio for the continent. This is where you find most of the marine life and a lot of our resources. Then, things get steep. You hit the continental slope, the true edge of the continent. And finally, at the bottom of that slope, you have the continental rise, which is like a big ramp of sediment that gently leads you down to the main event, the deep ocean floor. All right, we've left the continents behind us. We are now entering the deep ocean basin. And let me tell you, this is by far the biggest part of the entire ocean environment. So now we plunge down into the abyssal plain. And it's almost impossible to convey how huge this is. These plains cover more than 50% of the entire Earth's surface. And they are some of the flattest, smoothest places on the entire planet, thanks to millions of years of fine sediment raining down and covering everything up. But it's not all just a flat, featureless desert down there. Oh no. Dotted across these plains are an estimated 100,000 seamounts. These are basically underwater mountains and volcanoes. Some of them rise for kilometers from the seafloor, creating these incredible islands of biodiversity in the deep, dark sea. Okay, next up is a feature that is, and I mean this literally, the single most extensive geological feature on our entire planet. It absolutely dwarfs any mountain range on land. We're talking about the mid-oceanic ridges. Just try to wrap your head around this. It's a continuous chain of underwater mountains that snakes for 65,000 kilometers across the entire globe, connecting through all the major oceans. It's just like the seams on a baseball. And these ridges are geologically alive, constantly creating new ocean floor as hot magma rises up from the mantle. And this process is the engine that drives continental drift. Remember Alfred Wegener's theory about the supercontinent Pangaea breaking apart? Well, this is how it happens. Seafloor spreading at these ridges creates new crust, and that pushes the tectonic plates and the continents sitting on them apart. It's happening right now. So, we've climbed the highest underwater mountains. Now, let's descend into the deepest points on Earth, the oceanic trenches. This is truly our planet's final frontier. So how do you get a hole this deep? Well, they form at what are called subduction zones. This is where one of Earth's massive tectonic plates is forced to slide underneath another one, plunging back down into the Earth's mantle. It's a critical recycling plant for our planet's crust. To give you an idea of the depth we're talking about, let's look at the king of all trenches, the Mariana Trench. It's the deepest known spot on our entire planet. Let me put that number into perspective for you. You could take Mount Everest, the tallest mountain in the world, and place it at the bottom of the Mariana Trench, and its peak would still be covered by more than a kilometer of water. The scale is just mind-boggling. Now, all that grinding and crunching of tectonic plates has huge consequences. It makes these zones incredibly volatile. the stress builds up and releases in the form of some of the most powerful earthquakes on the planet, which can trigger devastating tsunamis like the 2011 earthquake off the coast of Japan. Okay, so we've seen all these amazing extreme landscapes. But so what? Why does any of this matter to us living up here on the surface?
Well, it matters a whole lot.
This really pulls it all together. You can draw a direct line from this deep sea geology to our lives. The continental shelf? That's where we get so much of our fish, oil, and gas. The mid-oceanic ridges? They're literally moving the ground beneath our feet. The trenches? They pose major earthquake and tsunami risks. And those remote seamounts? They're hotspots of life and could be future sources for critical minerals. Every single feature has a direct impact on us. And that brings us to a final, pretty humbling thought. It's often said that we know more about the surface of Mars than we do about our own planet's ocean floor. With so much of it still unmapped, we've barely scratched the surface of understanding our own world. So the real question is, what else is down there, waiting to be discovered?